Imagine, if you will, the perfect romantic evening. You are standing on a cliffside, holding hands with a generic stick figure partner. You look up, expecting to see the silvery, comforting glow of the moon, ready to recite a poem about beauty and eternity. But instead of a glowing rock, you see a dim, multicolored, festering sphere of refuse. It looks like a disco ball that was left in a microwave. It is the moon of trash. And before you can even ask, is that a used diaper floating past the sea of tranquility, you die. Okay, maybe not immediately, but we need to talk about what happens if we actually did this. What if we took the moon, our beautiful, rocky satellite, and replaced it with a spherical accumulation of all the garbage humanity has ever produced? To answer this, we first have to consult the ledger of human filth. We are a messy species. We produce roughly 2 billion tons of solid waste every year. If we look at the total anthropogenic mass, that's everything we've ever made. Concrete, metal, plastic, asphalt. It weighs roughly 1 teraton. That is 1 trillion metric tons. Now, that sounds impressive. You might think, wow, we could definitely build a moon out of that. Physics disagrees. Physics looks at your 1 teraton of trash and laughs. The actual moon weighs 73 quintillion kilograms. That is a 7 followed by 22 zeros. If we balled up every single scrap of human existence, every landfill, every skyscraper, every sunken ship, and put it in orbit, it wouldn't be a moon. It would be a pitiful little asteroid about 15 kilometers wide. It would be a barely visible speck. If you replace the moon with that speck tonight, the first thing you'd notice is that the night is pitch black. The second thing you'd notice is the screaming from the coastline. Why? Because gravity. The moon's gravity is the engine that drives the tides. It pulls on Earth's oceans, creating the bulging high tides. Our little 15-kilometer trash toroid has the gravitational pull of a golden retriever. The tides would simply stop. The oceans would settle into a stagnant equilibrium. Without the churning of the tides, nutrients from the deep ocean stop circulating to the surface. The marine food chain collapses, plankton die, fish die. The ocean turns into a giant, motionless pond of death. But that's a boring apocalypse. A tiny invisible trash rock is underwhelming. So, for the sake of science and visual horror, let's cheat. Let's assume that we don't just use our trash. Let's assume we invoke a magical garbage multiplier. We are going to replace the moon with a ball of trash that is the exact same volume as the current moon. A sphere 474 kilometers wide, made entirely of banana peels, styrofoam, broken iPhones, and single-use plastic bags. Now we have a show. The trash moon rises. It creates a spectacle unlike anything in astronomical history. Because trash has different optical properties than regolith, that's moon dust. It wouldn't shine with a clean white light. It would glitter. The plastics and metals would reflect sunlight in a chaotic, shimmering mosaic. It might actually be kind of beautiful, in a Jackson Pollock sort of way. But beauty is fleeting. Physics is forever. The first problem we run into is density. The moon is made of rock and iron. It's dense, about 3.3 grams per cubic centimeter. Trash is fluffy. Even if we compact it, the density of a landfill is usually less than 1 gram per cubic centimeter. This means our trash moon, despite being the same size, has less than a third of the mass of the real moon. This has immediate consequences for your calendar. The moon orbits Earth because of a delicate balance between its speed and Earth's gravity. If we suddenly swap in a lighter moon, but keep the speed the same, the trash moon is going to drift away. It will spiral out into a higher orbit. As it drifts away, our nights get darker. But more importantly, the Earth loses its stabilizer. Here is a fun fact about planetary dynamics. The moon acts as a celestial anchor. Its gravity keeps the Earth's axial tilt steady at 23.5 degrees. This tilt gives us our seasons. Without a heavy moon to weigh us down, the Earth begins to wobble like a dying top. Over thousands of years, the Earth's axis could swing wildly. The North Pole could point directly at the sun. Antarctica could become a tropical paradise, while the equator freezes over. Civilization would be forced to become nomadic, chasing the habitable zones as the planet drunkenly tilts back and forth. But you won't live that long, because we have to talk about the smell. You might be thinking it's in space. There's no air. You can't smell space. And you are correct. You cannot smell the vacuum. However, the trash moon is not a solid rock. It is a loose aggregate of volatile chemicals, liquids, and organic matter. In a vacuum, liquids don't stay liquid. They boil. Instantly. Imagine the millions of half-empty soda bottles, the jugs of expired milk, the industrial sludge, and the chemical waste buried in that sphere. The moment the vacuum hits them, they undergo rapid evaporation. The trash moon, begins to outgass. It wouldn't just sit there. It would develop an atmosphere. A very, very bad atmosphere. Massive plumes of methane, ammonia, hydrogen sulfide, and water vapor would erupt from the surface. The trash moon would start to look like a comet, trailing a massive cloud of garbage gas behind it. Earth's orbit passes through this wake. The upper atmosphere of our planet would begin to accumulate these particles. It starts as a haze. The sunsets turn a vibrant, sickly green. Then, the heavier molecules settle. The smell hits humanity on a Tuesday. It starts as a faint whiff of rotten eggs. Then, it escalates to burning rubber. Finally, the entire planetary atmosphere is permeated with the scent of a hot dumpster behind a seafood restaurant in July. But the gas isn't just smelly, it's a greenhouse gas cocktail. Methane is 25 times more potent than carbon dioxide at trapping heat. By wrapping Earth in a blanket of space garbage farts, we trigger a runaway greenhouse effect. The temperature spikes, the ice caps melt, the stick figures on the surface are now sweating, holding their noses, and watching the sea levels rise. But wait, it gets worse. Let's do a deep dive into the thermodynamics of decomposition. This is where the real horror lies. We tend to think of space as cold, and the surface of our trash moon would indeed be frozen solid. We'd have a crust of icy diapers and frozen lawn chairs. But deep inside the sphere, something alive is waking up. Bacteria, specifically anaerobic bacteria. These little guys love environments with no oxygen. They feast on organic matter, food waste, paper, wood, and as they eat, they do two things, and they produce gas and they produce heat. In a landfill on Earth, this heat slowly leaks out into the ground or the air. But in space, heat is nowhere to go. Vacuum is a fantastic insulator. It's why your coffee thermos has a vacuum layer. Heat can only escape by radiation, which is a very slow process. So, the heat generated by the bacteria inside the trash moon gets trapped. It builds up and builds up. The core of the trash moon begins to cook. Temperatures in the center rise to hundreds of degrees Celsius. The plastics melt, the metals soften. The organic sludge turns into a pressurized boiling slurry. We have inadvertently created the solar system's largest, nastiest pressure cooker. The pressure from the methane gas building up under the frozen crust becomes immense. The structural integrity of a ball of garbage is not great. Eventually, the crust fails. Imagine looking up at the night sky. The trash moon is glittering. Suddenly, a massive crack appears across the equator. Kaboom! A geyser of superheated, radioactive sludge erupts from the surface, shooting hundreds of kilometers into space. It's a cryovolcano, but instead of ice, it's vomiting molten trash. Because the gravity of the trash moon is so weak, this ejector reaches escape velocity easily. The sludge enters Earth's orbit. Congratulations. Earth now has rings. But these aren't the majestic, icy rings of Saturn. These are brown, jagged rings made of frozen medical waste, shards of glass and clumps of toxic slag. This is the Kessler Syndrome on steroids. Every satellite we have, GPS, weather, telecommunications, is shredded by the debris field. The internet goes down instantly. Global communication vanishes. We are back to the dark ages, except the sky is brown and smells like sulfur. And finally, let's talk about the biological hazard. The bacteria we launched into space. Some of them are extremophiles. They mutate in the high radiation environment. When chunks of the trash moon's ejecta inevitably deorbit and burn up in our atmosphere, they rain down these super bacteria onto the surface. We're talking about space-hardened E. coli and salmonella raining from the heaven. So let's recap the life cycle of the trash moon. We lose the tides, killing the oceans. We lose our axial stability, wrecking the climate. We get enveloped in a cloud of garbage gas that creates a permanent stench and heats the planet. The moon cooks itself from the inside out and explodes. We get pummeled by radioactive, bacterial sludge rings that destroy civilization. On the bright side, we technically cleaned up the landfill. The real estate value of New Jersey would skyrocket because it's finally cleaner than the sky above it. This thought experiment teaches us an important lesson about physics. Scale matters. The Earth and Moon operate on a scale of mass and gravity that we can barely comprehend. Trying to intervene in that delicate dance with our own garbage is like trying to fix a Swiss watch with a sledgehammer made of soup. The moon is fine where it is. It's heavy, it's silent, and most importantly, it's sterile. Let's keep our trash down here. Or better yet, maybe let's just stop making so much of it. Because if we don't, the only space we're going to run out of is the space to live. Thanks for watching. If you enjoyed imagining the smell of a celestial landfill, hit that like button. If you didn't, well, just be glad the internet still works. I'll see you in the next one, before the entropy claims us all.